All right, I'm out here again with my 3D printed Cinewhoop, and before I go over what I changed, I'll go over real quick what we have so far in this drone. All right, so I designed a 3D printed frame, and that's what I'm using. This is made up of PCTPE, I believe, and this is Nylon X. And what I've noticed, you can see all the grass marks. I don't know if you can see it in the camera, but it has plenty of grass marks from landing, a little rough every now and again. I've ran it into a whole bunch of stuff. This frame here has not broken so far. I'm not racing with it, so I'm not going full speed into anything. But just for a typical Cinewhoop type of flying, I haven't had any issues with the frame itself breaking. And I believe that's because of using this PCTPE and using this Nylon X. All right, for motors, they are pretty underpowered, but they work. I'm using the Echo 2 Emax motors, 3-inch frame that it's on. I'm using Flywoo Goku 45 AIO all-in-one, and I have a Rush FPV that I took out of another drone. This is an 800 milliwatt system on here. In the front, I have the Maytech optical flow and LiDAR right here, and here's a LiDAR. So the reason why I have two LiDAR systems, I'm using this one for optical flow for position hold, and the LiDAR only goes up a couple feet, so it kind of makes it useless. So I'm not using the LiDAR in here, just the optical, the camera to look at the ground, and I'm actually using this LiDAR for my altitude. So again, everything's 3D printed. The red parts are all made of TPU. Makes it so that when I hit the ground and stuff, it's not going to break. I think that helped out a lot also. Okay, so the main difference between my last video and this one, I believe in the last video I had GPS in it. I took the GPS out because this is, for me, I designed it to be kind of an indoor search and rescue drone, not for outdoor. Cinewhoops typically don't have a long battery life, so you wouldn't be using it to fly around outdoors for a long period of time. So I just wanted to be able to have something that you get indoors, fly around, and you're able to see. So you can see where some kind of a first responder or anyone like that could benefit in having a drone like this. And with it being 3D printed, that makes it easy if something breaks. The cost is a lot lower than if you to buy something similar off the shelf, and it's not too hard to configure. So also before, I had an infrared camera with a Raspberry Pi, and again, to keep it cheap, I got rid of all that. I was just thinking one day, I was like, wait a minute, there's backup cameras in cars. This is actually a car backup camera on here. So I noticed that the backup cameras had a red, yellow, and black. So it's analog video with a red and black, which is 12 volts. So it worked out perfect, and I can fly this day and night. And I'll let you see how it flies in the day. And I'm also going to show you, hopefully I have the video of when I went to a fire department and flew it around. I was able to go in an elevator shaft because of the LiDAR and the positioning up front with the optical. I was able to go up and around staircases pretty easy, and yeah, it came out a lot better than I thought it was going to be. So here you can see underneath, this cable actually goes, the video cable goes into the camera, and then my red and black go into this BEC right here, and it's 12 volts, so it's going straight to the battery, and here it's converting it into 12 volts for this. So I did make a lithium-ion battery because I wanted to get the maximum amount of flight time on it. So I did make lithium-ion battery packs for it, just using four 18650s, and this worked out pretty good. I got the 26 amp batteries, and I think this drone usually goes a max of 2021. So this does get warm, but I'm able to fly for a pretty long time just using this lithium-ion, instead of using a regular LiPo. All right, for the controller, I'm using ELRS, and I don't have the all-in-one ELRS controller, so I do have the module on the back of this one. That's just what I had when I bought it. And then I'm using the Emax transporter, came with their goggles, but they came with a detachable screen. So I'm using this screen with a 3D mount on here. So Again, if you're using it for first response, you're not going to have goggles on you and everything, so you can use this screen and look at where you're going. If you haven't already, please like and subscribe to my channel if you haven't already. It'll really help me out a lot. As you can see here, these are all of the ones that didn't make it. These are all my prototypes that I tried before. Some worked, some didn't. Some worked better than others. But it's been a long time printing all this stuff to get it to work, and it's costed a good amount of money. So yeah, just you subscribing really helps me out. If you really want to go the extra mile, I have a Patreon and a Buy Me a Coffee link down below, and that would help out and make it to where I can make these videos a little faster, because I do want to get a bigger 3D printer to make a bigger frame, and I do want to add a digital system to it. So as you can see, the analog video when we fly it, it's not the greatest, even though I have, maybe it's not the best VTX that this has, but this 800 milliwatts, once I get around the house, it's not very good. But if I'm using my digital walk snail and I go behind the house, I have no problem. So I do want to upgrade this to some kind of a digital system, either HD0 or the walk snail low light, and try to figure out something from there. That's the future of this. Also, I want to add a servo to the front of this so that if you want to go down an elevator shaft or up, you can tilt it all the way down and all the way up, so you can really pay attention to where you're going, and that would really make this different when it comes to indoor flying. And that's it for now. Let's go ahead and get it in the air and see how it does. Okay, let's go ahead and get it in the air. And I'm in angle mode right now. So here it is in regular angle mode. It doesn't hold position. It doesn't hold altitude. I'll switch to altitude hold, which is my middle switch. Now I can maintain altitude, but it'll still drift around. And now I'll go ahead and lock it into, bring it up a little, into position hold mode or hold mode. And that's by pushing it all the way down. And now I'm in hold mode. So even though I'm outside and I don't have GPS, so I'm not going to have it to where it comes back and returns to home. As long as I can see it, I'll know it's going to maintain its position and it's going to maintain its altitude, and it really helps out when you're flying indoors. Let's go ahead and check it out, check out the camera. And this is all flying outside in the daytime. So I'm able to fly down here into the shadows. And again, this is all analog, and I'm not sure if this VTX is not very good or if this is normal for analog, because I did switch over to digital on my other quads, and this does seem to be doing pretty good. But now I'll try to go around the house. And you'll start to see some breakup. It's a lot more breakup than if I had the digital system out. I wouldn't have this much breakup. And let me just show you this altitude hold working, or this position hold working, and altitude. I'll go ahead and stop it here. It's looking down at the ground and it's maintaining position. So I'll bring it closer so you can see it. I'll bring it back towards me and then let off the sticks. Maintaining altitude, maintaining position by looking down at the ground. So hold is working. Now I'll show you that the altitude is working. I'll get it low to the ground. Notice it says 4 feet on the right. Don't worry about the blinking battery light. This is using lithium ion. I can go down to 12 volts. That's why I use that. So now if I just went and I'm flying and I go down lower, I'm flying under the trees, and I could just use my right stick because it's going to maintain its altitude. and go up when it's going uphill. See it going up? So it just makes it a lot easier to fly, especially when you're indoors. And it actually helped out when I was going around steps or going up over steps. Okay, so now while this is flying around, I'm going to talk to you about when I flew it indoors at a fire department. Hopefully I have the video running right now. I went ahead and took it indoors. A lot of metal, a lot of interference. But even with that said, I was able to go up steps. I was able to go into elevator. And that's when I saw while I was in that elevator, I can't really go up. It makes it hard to go up when I can't see above me. So that's why I want to go ahead and add servo gimbal to it. But I can't do that because I'm using INAV, I can't do it with this flight controller that I currently have because it only has motor pads, 4 motor pads, and you need to use extra motor pads to hook regular analog servo to. So what I have to do is get a different flight controller that has, let's see if I can see through here, a different flight controller that has 8 motor inputs or at least more than 4. So that way I can use those extra motor ports and use that to map the servo and use that for tilt. So I'm at 5 minutes and I still have a whole volt to go. Again, you can go down to 12 volts with this. So I'll just keep on running. So I can go under these trees, can fly around things, a lot more comfortable if you're a novice at this and don't know what you're doing. Again, this isn't made for outdoor flying. It's more made for indoor for me. And we'll be doing some more testing with it indoors, especially in the dark. The infrared works very well, but again, I want to get a digital system. This cheap camera worked a lot better than I thought it was going to, and I'll get it out in front here so because you really can't tell with that. But now that you can see here, this is a normal view with it being line of sight, nothing in the way. The camera doesn't look bad at all, especially to see what you're trying to see. Okay, I'm not going to go all the way down to 12 volts because I don't want to have it crashing down. I'll bring it down when I hit about 12.4. Again, I'll stop it for position hold. Bring it back. Position hold. I'll take it out of position hold, put it in altitude hold. And notice it's drifting. I flip it back into position hold and it stopped drifting. And if I put it in angle mode, now I have to maintain my altitude manually. So I'll go ahead and flick it back into altitude hold mode and go ahead and bring it in. All right, that's it for this video. Again, I wanted to show you the updates I made to this drone. Take the battery out before it gets too hot. And if you know any people that are into search and rescue, you know any cops, firefighters, show them this video. See what they think about it. Let me know in the comments. Share the video with people that may be in this industry. This is something that I've been working on for a while. I only plan to improve it. Again, it would help me out a lot if you were to at least subscribe to the channel, leave a comment. But it would really help me if you went ahead and used the Buy Me a Coffee link or Patreon. That would really support me and get this thing going a little better, a little faster, because I'll be able to get the money faster to buy the different parts for testing. This is all test stuff, trial and error with a lot of this equipment that I've been using, a lot of trial and error with the different materials that I'm using for the frame, but it seems to be working out very well with the Nylon X, and the PCTPE that I'm using on here. That's it for this video. I hope you liked it. And again, please like, subscribe, and we'll see you next time. Thanks for watching.